Hi everyone, this is your math guru. In this video, I'm going to explain how to use the double angle identities. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. For your cosine, you have three different double angle identities. For your sine, you have one, and for your tangent, you have one. So depending on what the question says, you can pick either. And in this video, I'm going to show you how to expand and go forward, or how to contract and go backwards. Let's start with a couple of examples. If I have cos of 10x, I know that 10 is a multiple of 2, so I can break it down into cos of 10. If I'm breaking down 2 as a multiple, I have that as 2 times 5. So breaking down my 10x, I have that as 2 times 5x. Such that if we look at my identity, I have 2 alpha going to alpha cos squared alpha minus sine squared alpha. So what that means is, if I use the breakdown that I have as 2 alpha, my 2 remains 2, and my 5x will be my alpha. So if I use the first breakdown, I'm going to have cos squared alpha in this case is my 5x, minus sine squared alpha. So I have sine squared 5x. If I use the second expansion, I'm going to have 1 minus 2 sine squared alpha. Remember, my alpha is 5x. Or if I use the third expansion, as shown, that will give me 2 cos squared alpha. Alpha in this case, I'm going to change that to my 5x minus 1. So what it means is I have 3 different options for cosine. If I go to my sine and I to expand sine 6x, I know that 6 is a multiple of 2. 2 times 3 makes 6. So I'm going to rewrite that as a double angle. I have sine 2 times 3x. So therefore, because I'm using the expansion of 2 alpha, what it means is my 2 remains 2, and my alpha in this case will be 3x. So therefore, to expand using the double angle identity, that will be 2 sine alpha, remember my alpha is 3x, times cos alpha, alpha remains 3x. And for tangent, if I'm to find the tan of 8x, that will be, I'm breaking down 8, 8 is a multiple of 2, so that will be the tan of 2 times 4x, 2 times 4x will give me 8x, and note, in this case, my 2 remains 2, and my 4x will be my alpha or a, as shown in the expansion above. So therefore, what I'm going to have is, I'm using this expansion, I have 2 tan, I have a, which is now 4x, divided by 1 minus tan squared a, which is 4x. Let's look at more examples. Using cosine as my example, if I'm to find cos 60 degrees using the double angle identity, 60 is a multiple of 2, so using the first expansion, I have cos 60 equals cos 2 times 30 degrees, such that my 2 remains 2, and my 30 will be my alpha. So therefore, for my first expansion, that will be cos squared alpha. So I have that as cos squared 30 degrees minus sine squared 30 degrees. I can rewrite that as cos 30 degrees all squared is the same value minus sine 30 degrees all squared. And using my special angles, cos 30 is root 3 over 2 all squared minus, I have cos 30 to be root 3 over 2, then I have sine 30 to be 1 over 2 all squared. Simplifying, I have that as 3 over 4 minus 1 over 4, and that's 2 over 4, and if I simplify further, that will be 1 over 2. If I use the second expansion, I have cos 60 degrees equals cos 2 times 30 degrees. I have my 2 as 2 and my 30 as alpha, and using the second expansion, I have that to be 1 minus 2 sine squared alpha. Alpha is 30. I can rewrite that as 1 minus 2 in bracket sine 30 degrees all squared. That's 1 minus 2 times, using my special angles, sine 30 is 1 over 2 all squared. Simplifying, that's 1 minus 2 times 1 over 4. And simplifying further, I have that as 1 minus half, and my final answer is 1 over 2. And I'm going to use the last double angle identity for cosine. I have that as, I have my cos 60 equals the cos of 2 times 30 degrees, and I have my 2 and my alpha, such that I have 2 cos, I'm using the last expansion, that will be 2 cos squared alpha. Alpha in this case is 30 degrees minus 1, that will be equal to 2 cos 30 all squared minus 1. Using my double or my special angles, that will be 2 times root 3 over 2 all squared minus 1. That's 2 times 3 over 4 minus 1. And if I resolve that, that will be 3 over 2 minus 1, and 3 over 2 minus 1 will give me 1 over 2. If you look at all the expansion I've used, irrespective of which one, my answer remains 1 over 2. Now, for the last part of this exercise, assuming you're given the expansion, if I have, for example, 2 sine 2x cos 2x, and I'm to go back to my original double angle expression, you can see that I have the same angle, 2x and 2x, so I can call that my alpha. And if I look at the double angle identity that looks like this, it's the one for sine as shown. So if I'm to go back, I'll have that as sine in bracket 2 times alpha, so I have that as 2 times my alpha, in this case is 2x, so therefore that will be sine 4x. I'm going to give you another example. If I have, that's my A, my B example, if I have cos squared 3x minus sine squared 3x. If you look at my expansion, I have 3x to be the same, so I can call that by alpha and alpha. And if I look at the identity that has cos squared alpha minus sine squared alpha as shown, that will be the first expansion for cosine. So therefore, if I rewrite that, that will be cos in brackets 2 times my alpha. Alpha in this case is 3x, and that will be cosine of 6x. And for the last example, if I'm to use my tangent, and I have 2 tan 5x divided by 1 over 1 minus tan squared 5x. I can see 5x common, so I'll call that my a and a. And if I use the last expansion, that's for tan 2a, what I'm going to have is tan of 2 times my a, in this case is 5x, so I have tan of 5x. Therefore, that will be tan of 10x. Thanks for watching. Bye.